page 87, question 2, developments. So we're continuing on with the developments questions. This question is an Amicelli box. So we'll go through the question first and then we'll explain a few bits and pieces. The Amicelli box shown across is based on a regular hexagonal prism. Using the dimensions shown, draw the elevation of the prism looking in the direction of arrow A. Draw the plan of the prism looking in the direction of arrow B, projected from the plan. Draw the surface development of the prism. So we're going to go through what all of that means. We have our chocolate box. It says it's based on a regular hexagonal prism. What that means is that the shape of it, the main shape of it, is based on a hexagon, and a prism is the opposite of a pyramid. A pyramid goes into a point, whereas a prism does not. You'll notice this box of chocolates stays the same width all the way up along, so it doesn't go into a point. So just to show you the difference, as we said, this is a regular hexagonal prism. This would be an example of a hexagonal pyramid. The base of it is based on a hexagon, but you'll notice it goes up, it gets narrower as it rises up, and it goes into a point at the end. So this is a pyramid. We have our prism. We have to draw the elevation of the prism looking in the direction of arrow A. The elevation is the front. So our arrow A is in here. The question is telling us that this is the front of the object, this regular hexagon. We have to come along afterwards and draw a plan of the prism looking in the direction of arrow B. Very important here, projected from the elevation. So what that's telling us is that I have to take construction lines down from my elevation to draw the plan view. Plan view is if I look down on top of it, you can see the arrow B there, look down on top of the box, and I'll see these top three surfaces. I'll see 1, 2, and a surface the far side. I won't see these surfaces underneath, the three rectangles underneath, because they're hidden. The three on top are the ones I'm going to see. Part C then is draw the surface development, and we said the surface development is where we get the box and we flatten it out. So if I wanted to make this from one piece of cardboard or one piece of paper, what shape would I need? That is the surface development. Okay, we'll get started on the question. Starting with our elevation and plan. For your XY line, you can measure down about 100 millimeters from the top of the page. So you can see it here. So for my XY line, let's measure down 100 millimeters. I'm doing it on the left hand side, so I'm going to put my elevation and plan here so that I've got space over on the right hand side of the page for the development. We were given one dimension for the box. The Amicelli box, we said, is based on a hexagon of side 35. So that's the one measurement I need for the elevation. To draw the hexagon, each of the sides are going to be 35 millimeters. So I've got my XY line drawn in. I'm just going to pick a point at the start of it. We'll pick a point here, and I'm going to measure out 35 millimeters, so 30 and 5. Our hexagon, we did it a few times earlier in the year, is based on a 60-degree angle. 60-degree set square, this is the angle I'm going to use. Always off the T-square. You can't draw a 60-degree angle freehand because there's no way of knowing when it's exactly 60 degrees. So always off the T-square. I'll come out with the construction line, and I need to rotate the set square to draw the other side. So rotate it around and slide it across. Construction line out the far side. Any length. Just make sure they're nice and light. I'm going to copy the length of the base with the compass. Instead of measuring it all the time, copy that length, and I can just strike off that length on each of my construction lines. Again, I can come up with my 60-degree set square, and I'll draw a light construction line. Any length. Once again, I have to flip the set square. And 60 degrees in the other direction. I haven't changed the compass. The compass is still set to 35. Just to check it, Here's my 35 measurement, and I'll strike off the top two sides. Last thing I need to do then is just with my T-square, I can draw a horizontal line across between those 2 points. That is my hexagon drawn in, and it's just a matter now of darkening it in. Don't darken it until you've got the full thing drawn and you know it looks right. That's the plan complete. Now it said in the question this is the elevation complete. Now it said in the question, from the elevation I have to project my plan view. And what that means is I need to connect the two drawings together. So with my T-square and set square, I'm going to draw construction lines straight down to bring each of the 6 points down. So my corner on the left, my top point, which actually lines up with the bottom point, and it should, the other top point, and that again should line up with the bottom point, and the point on the very right hand side. And what that's doing for me is copying the width of the elevation. So I've taken the width of it down, and I've taken the width of this top section down. To start the plan, we always step down 20 millimeters. And I've drawn in the first line of the plan. The line I've just drawn represents this back surface. So the back hexagon. On the question, it says it's a distance of 120 millimeters from the back to the front. So from the hexagon at the back to the front is 120 millimeters. I've drawn my back hexagon. It means I need to measure down 120 millimeters. Down 120. And I draw my line across. Now I come along and I darken in those vertical lines. So to go through what the plan view I've just drawn represents. The front hexagon, which is a flat vertical surface, is here. The back hexagon, which again is a flat vertical surface, is here. The top of the box, which is a rectangle, is here. This rectangle on the right hand side, which is slanted, is here. And then we have another surface that's actually hidden in the 3D view, which is another rectangle that's slanted, and it's here. So that's our elevation and plan. Part C of the question now is draw a surface development of the prism. In other words, we have to flatten this out. First of all, I want to figure out how many bits are in the development and what each piece is going to look like. I've got a front, which is a hexagon. I've got a back, which is a hexagon. And then I've got rectangular surfaces. And each of these rectangular surfaces are all the same size. And there's going to be 6 of them. They're all 120 millimeters from front to back. And they're all 35 millimeters wide. So in total I'm going to have 8 surfaces. 6 of them are going to be 6 of the same rectangles. I'm going to have a hexagon for the front, hexagon for the back. I'm going to go through drawing those now. To start it off, from the top of the page you can measure down 80 millimeters. So it's down 80, anywhere at all. And we're going to draw a horizontal line to start off. Construction line, it doesn't need to be dark. any length across the page. We're going to start by drawing in the 6 rectangular pieces, and we're actually lucky because we've got the true shape of one of the rectangles. In other words, what the rectangle really looks like. We have a rectangle here, but that isn't what that side really looks like. This one is. This one is 35 millimeters wide by 120 millimeters long or high. I can just copy 6 of those out. The quickest and most accurate way to do that, measure down 120 millimeters. Again, a horizontal line across. And I'm going to start over here with the vertical line. So that's my start point. I need 6 rectangles that are all 35 millimeters wide. I know this measurement is 35 millimeters. So I can come along and step out 6 distances. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6 rectangles. Just make sure you've got 6, and we've got a vertical line in the end. I've got fold lines that I'm going to draw in, so I know exactly where to fold each rectangle. Those 6 rectangles will make up the main body of the chocolate box. Now I need to come along and I need to put a hexagon down here for the front, hexagon for the back. To draw that is the exact same as how we drew this one. There's a slight difference when we come to the bottom because we have to work from the top down. It doesn't matter which line we start at, it makes no difference. I'm going to pick this one, and exactly the same as before. 60-degree angle from the T-square, 60-degree angle again. Copy my measurement of 35, and I copy that measurement down on each side. Once again, my 60-degree angles, 60 and 60. And copying my measurements down. 35 and 35. With my T-square then, I could draw in the bottom of it. Once again, when I know it looks right, I can darken that in. I can do this freehand because I've already got the construction lines, so I'm just darkening in a line that's already there. Exact same on the top, and again I can put the hexagon anywhere I want, it doesn't matter. Just to make it look right, I'll draw it above where I've drawn the other one. 6-degree angles in both directions, and again my 35 millimeter measurement. Come off 60 degrees and come off at 60 degrees. I'll put my 35 and 35. And again off the T-square, draw on the top. And again I can darken it in freehand because I've already got the construction lines there. That is my development done. You can cut that out and then stick it together, and by doing that you'll know how accurate you've got this question done. If it goes together, you know you've got the right shapes. If it goes together really well with no gaps, then you know you've drawn this really accurate. Okay, give it a go.